Welcome dear students. Let's continue with exercise 9a, and this is gonna be the last video on exercise 9a. Okay, so the first problem for the day, I'm taking question number 10. In the given figure, AB is equals to DB. So you see AB is equals to DB. We can clearly see from the diagram, and AC is equals to DC. So AC is equals to DC. So all these measurements are given. Angle ABD is 58 degree, DBC is 2x minus 4 degree, ACB is y plus 15 degree, and angle DCB is 63 degree. Now you see there's x out here, and here you have got y. So what you need to do is you need to find out the value of x and y. Okay, so how to do that? So for that, what will I do is I'll show that this triangle is congruent to this. Okay, so let's see how to do this. So from the figure, okay, so that is in triangle ABC and triangle DBC, what you see here is we see that AC is equals to DC, right? So this is given to us. AC is equals to DC, AB equals to DB is also given, AB equals to DB is also given, and in both the triangles one side is common, and that side, common side, is BC. So that's why BC equals to BC, which is common out here. Okay, so let me change the diagram now. Okay, so see, this red represents the corresponding parts, blue represents the corresponding parts, and this black represents the corresponding part. So what is happening here is you have S, 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 isn't it? S, S, S. So using SSS, we have triangle ABC and triangle DBC, both are congruent to each other. Okay, now by CPCT, obviously you're going to have angle ABC. Okay, so see here carefully. So basically this angle will be equals to this much. Okay, that is angle DBC, and angle ACB, that is this one, is gonna be equal to angle DCB, that is this angle. Okay, so this is by CPCT. Now we will make use of this thing, whatever we got, and we'll make use of the thing that is given to us. Okay, now given is angle ABD is equals to 58 degrees. See here carefully. ABD is this entire angle. Okay, is this is entire angle. Now all of you know that this angle and this angle, they are equal, and when you add these two angles you get ABD, isn't it? So that's why in place of angle ABD, what I have done here is I have written ABC plus DBC. Okay, so this plus this, that's what I have written out here. Now let's see what is given to us. Okay, so we are given DBC, angle DBC, isn't it? Have we given angle ABC? No, but you know that angle ABC and angle DBC both are same. So here what I have done is, in place of this I'll write DBC. Okay, angle DBC plus angle DBC will give you 2 times angle DBC. Now you know angle DBC is given to you 2x minus 4, isn't it? Now you need to open the bracket and find the value of x. Okay, so I don't have space here. You may pause the video and note down till here. Right, so we know that when you open the bracket you get 4x minus 8 equals to 58. Now from here calculate the value of x, bring this out here. So 58 plus 8 is 66. Now bring this 4 to the denominator, 66 by 4. That's what you're going to get. Do the cancellation, you get 33 by 2, and if you convert this into mixed fraction, the value of x turns out to be 16 and half. Right, so we got the value of x. Now we need to find the value of y, isn't it? Now we know that by CPCT we have got this also, right? That is angle ACB is equals to DCB. Now let's see, what is angle ACB given to us? It is y plus 15, and angle DCB is given to be 63 degrees, isn't it? So let's find the value of y. So you get the value of y to be 48 degree out here. Okay, so you may pause the video and note down your solution. Now let's look at this particular problem. So in this question says, in the following figure, AB is equals to AC and AD is perpendicular to BC. Okay, so you see AD is perpendicular to BC. BE bisects angle B. So you see the line BE, this bisects angle B. Okay, so angle B is getting bisected, so that's why this is equal to this angle. Okay, and EF is perpendicular to AB. Look at the diagram. EF is perpendicular to AB. We need to show that BD is equals to CD. So we need to show that BD is equals to CD and ED is equals to EF. So ED is this one and EF is this one. So these two are equal. That's what we need to show. Okay. So let's see how to do this problem. So let's observe two triangles ADB and ADC. Let's see. ADB is this triangle and ADC is this triangle. Okay. Now just look at this. Now here what happens is, see here carefully, angle ADB is equals to angle ADC. ADB is this angle and ADC is this angle, and both of them are exactly 90 degree. So that's why they are equal. Okay, now see, this is given. Okay, and one more thing is given, and that is AB equals to AC. So this is also given, right? AB is equals to AC, that is also given. Now if you look at these two triangles, there's one side common, isn't it? And that side is AD. So what is happening? ASS, isn't it? Right? So no, not ASS. You can say it is RHS, because this is right angle. Okay, and this acts like hypotenuse and this acts like your one of the side, isn't it? So this is your right angle, hypotenuse and side. So using Rhs congruence, what we can say here is, we can say that two triangles ADB and ADC, they are congruent to each other. All right, so if they are congruent to each other, so what I can say here is, I can say that by CPCT BD is equals to DC. Okay, so that's what we need to show here. Okay, now let's see the other part. So for other part, I'm going to make use of two triangles EFB. Look at this triangle EFB, and the other triangle is EDB, that is this triangle. Okay, now if you look at these two triangle, there's one angle common. I'm sorry, there is one angle which is 90 degree, and that angle is this angle. So this is 90 degree and this angle is also 90 degree. Both of them are 90 degree. Now you see this angle and this angle, they are also equal. This is given to us, right? And there's one side which is common, and that side is EB, isn't it? So EB is common to both the triangles, this triangle and this triangle. So that's why using angle side, we can say that these two triangles are congruent. Now if these two triangles are congruent, then obviously by CPCT EF is going to be equal to ED, and that's what we need to prove in this problem. Okay, so you may pause the video and note down the solution. Let's move to the last question. So this is not question number 10. I think this is question number 15. Okay, right. So which question was that? Yes, this is question number 14. This is question number 15, not 10. Okay, please make the correction. Right. So here, using the information given in the figure, you need to prove that AB is equals to EF and BD equals to CF. Now let's try to understand the meaning of the diagram. Here you see one arrow, and here also you see one arrow. So it means that AB and EC, it is FE, are parallel to each other. Okay, so AB and FE, they are parallel to each other. Now this is not the arrow. So AC and ED, so they are given to be equal. Okay, so this is another thing that is given, and one more thing is given to us, that is this angle, that is ACB is equal to EDF. Okay, so this angle and this angle, they are also equal. So these are the things that are given to us. Okay, so AB is given to be parallel to EF, as I told you. Okay, so if these two are parallel, then you see there's a Z type of figure. So that's why we can say that this BF is what? BF is the transversal. Okay, so a line cutting two parallel lines is known as transversal. So BF is your transversal. So let me redraw the diagram, same diagram. Now here in the diagram, you see there is a Z type of figure, and this angle automatically becomes equal to each other, and we call this angle to be alternate angles. Okay, So in triangle ABC and EFD, so what we have is, we have got this angle ABC is equals to EFD, okay, and this is happening due to the alternate angles, okay. One angle is given to be equal, that is this angle is given, okay, and one side is also given, okay. So this side is given to be equal to this side. So what is happening here? Angle side is happening, angle side is happening. So that's why using AAS we have triangle ABC is congruent to triangle EFD. So if they are congruent, then obviously by CPCT what I can say is AB is equals to EF, okay, right. Now you know also BC is equals to FD, isn't it? By CPCT BC will be equals to FD, okay. Now can I write BC as, look at BC, can I write BC as BD plus CD? Similarly I can write FD as this, FD as CF plus CD, isn't it? So DC and DC, they can be cancelled. So from here what do you get? BT equals to CF, isn't it? And that's what you are asked to prove here, okay. So you may pause the video and note down your solution, and with this we end this particular exercise. Thank you very much.